Welcome to the Intermediate Value Theorem. I will state the theorem and then prove it. For a function continuous on a closed interval of the real numbers, with the assumption that the value of the function at the left endpoint, capital L, is less than the value of the function at the right endpoint, just for convenience, so we could talk about the interval. Were it the other way around, everything would be the same. So for every t inside this interval between the value of the function at left and the value of the function at right, there exists an x that maps to that t. So it tells us that the function takes on all values between the values it takes on at the endpoints. To prove it, we will consider a set of all domain values such that f of x is less than or equal to the t value that we may be seeking to find the preimage of. So, since this is a subset of a closed set on the real numbers, certainly it's bounded, so it has a least upper bound, and we're going to talk about a domain value called x sub c. That's going to be the name of the least upper bound of that subset of the domain. We're going to look at possibilities for the value of f of x sub c and see if we aren't left concluding that f of x sub c is in fact t. If we look and see, at the assumption that f of x sub c is greater than t, we have to also remember that the function is continuous. And because it's continuous and f of x sub c is greater than t, there is a neighborhood around x sub c where the function is greater than t. And specifically, there's considering the neighborhood to the left of x sub c, since we have values less than x sub c with f of x greater than t, then we arrive at a contradiction with the assumption that x sub c is the least upper bound. Certainly it is an upper bound, but it is not the least upper bound. So, because of this contradiction, we must abandon the premise that f of x sub c was greater than t. Similarly, we could assume f of x sub c was less than t, and with the hypothesis that f is continuous, we're left with a neighborhood around x sub c such that any x in that neighborhood, f of x is less than t. Since we have values to the right of x sub c, where f of x is less than t, then x sub c simply can't be the least upper bound of the set A. So we have a contradiction, and now we must abandon the assumption that f of x sub c was less than t. Just putting it together a little bit here, we have f of x sub c greater than t cannot be, and it also cannot be less than t, so we must assume that f of x sub c is t. Now we have our domain value that evaluates to t, and so we have the conclusion of the theorem, basically. Again, the intermediate value theorem, f is continuous on a closed interval. Whatever the values at the endpoints are, there is always some domain value that will map to any value in between the function at the endpoints. That's the intermediate value theorem.